Hey folks, so today we'll talk as usual about the artificial intelligence memory for the agents and all other things. So I made a couple of articles already and a couple of talks about the semantic spacetimes and smart spaces. So it's quite interesting concept that use the graph as a modeling. But the root of this concept came us from the physics, because the guy who built the theory, that's actually the physicist, that we could say that we have the space-times in real life, that you have the locations and coordinates and all of things, and then the time is some kind of changes of the parameters in a space. And when we talk about the semantic space-time, we start using the location defined by the some kind of semantical distance, and we could measure the semantical distance in a different ways, but we model the similarity links as a graph edges that are weighted. And I had the article and video about the similar to relation, and we talk a lot about this, how we could use it, how the multi-dimensional similarity could be important, how the contextual and pragmatic similarity is also important. But in this semantical space-times graph, we have quite simple ontology of the four links. And the second link in the list is lead to. So it's causality relations, and causality relations lead us to the causality graphs. And causality graphs actually lead us to some directly cyclic graphs, and directly cyclic graphs are really matters for the events and causality relations, because when we're talking about the causality, we usually mean the events as an entity. So it's more about entity graphs. And the leads to could be it enough. I definitely don't think so. We still could use it as a high level ontology link that could have some subclasses of the links and all other things, but it's quite interesting idea that in this semantical space-time that model the human-like memory, we have some causal links and causal graphs. And we have a lot of causal inference algorithms and all the things, but what's interesting that we're not focusing on time, we're not focusing on meaning, we're focusing how these events connected to each other, and how one event lead to another set of facts, properties, changes of the facts, changes of the properties. That's why the causality similarity could form the space itself. So you just form the graphs that could have the spaces dictated by causality links and causality distances instead of the semantic similarity distances. So you could have subspaces that are more contextual. You could have the subspaces for some particular life experience that try to analyze how we get to this life experience, how we could benefit from it, or maybe what kind of events lead us to these results. And it's quite crucial when we're talking about the artificial intelligence agents that more focused on the personal assistance, emotional support, better life decisions, and all other things that really matter to build the better understanding of yourself, the better understanding of your own decisions and all other things. That's why the causality is crucial actually for the understanding of the events, the life experiences and all of that. And I still believe that semantical spacetimes theory and the smart spaces as a result would be crucial for the artificial intelligence agents, and we need to understand more why. We need to understand why some things happens, not where they happen or with whom they happen. And right now I do a lot of research in this area, and I will be happy to share these results with you in my next videos. But it was the next video about the semantic space times and the causality links. So that's it, what I was keen to share with you. See you next time. Choose.